we can specify the metric type that will be used for the routes that we are redistributing into OSPF. What's the point of this? Why do we even care about messing around with a metric type? Well, the metric type ultimately determines how the overall metric is going to be calculated by the routers inside of our OSPF domain. We still supply a seed metric. For example, by default it's 20, but you can supply whatever you want. From that point on, though, how is R4 or R3 or R2 or R1 going to calculate the overall metric in order to reach that external routing domain? Well, if we are using E2, which it is by default, whatever seed metric is specified is going to be injected into that route at that redistribution point. But now when R4 receives that, since it's an E2, it doesn't modify the metric at all. R3, the same. It's not going to modify the metric. It leaves it as 20. R2 leaves it at 20. R1 leaves it at 20. So even though we have these gig links with costs of 1, we are still dealing with an overall metric, if we just focus on R1, of 20, no matter what. So the cost of the route to get to that external routing domain is going to be the external cost only. That cost that was specified when it was redistributed. You might be thinking, sweet, load balancing. Not exactly. Not exactly. Here's what happens when we're using E2 and the cost is the exact same. In this case, it's 20. Since the cost is the exact same, R1 now looks at the cost to reach the autonomous system boundary routers. What is the cost to reach the autonomous system boundary router of R5? 1, 2, 3. It's 3. What's the cost to reach the autonomous system boundary router of R6? 2. Which one's lower? Which one's lower? This way. Therefore, we're not going to be performing load balancing here. R1 is going to choose based on internal metrics which ASBR is the closest. And in this case, it's R6. So therefore, we will go through R6 to reach that external routing domain. Now, if the internal costs were equal, for example, let's remove R4 from the topology, and we'll provide a directly connected link here, which would have a cost of 1. Well, yeah, in this case now, what? The internal cost would be equal to going either way. So what does that mean for us? It means in that case, we would have load balancing. All right, so we're only going to get load balancing if the internal cost and the external cost are all equal. So E2 being 20, and then the internal cost to get to both ASBRs is equal as well. But in this case, we wouldn't get load balancing simply because the top path is longer to get the ASBR than the bottom path. So you might be saying, well, what's the benefit of this? Here's the benefit. We use E2 when we want to have our routers inside of our organization make their routing decision strictly based on the external cost. We don't even want them to consider the internal cost whatsoever. So what I can do here is I can manipulate that E2 metric. For example, if I want R5 to be used as the primary exit point out of the environment. Well, let's change this cost to what? 25. If I change this cost to 25, now which path is going to be used? R1 sees that, oh, it's 20 if I go to R5. So it's going to go through R5, the ASBR. So you get to control the exit point out of the OSPF autonomous system simply based on the seed metric that's introduced into the routing domain. So what about E1? E1 now gives you control over the end-to-end cost. From each and every single router, they get to make the best routing decision based on internal metrics and the external seed metric. So as we see here with E1 now, when the E1 route gets injected, this router sees it as what? It sees it as 21. 21. And then this router sees it as 22. And this router sees it as 22 and 23. That's what it sees it as. So now, based on the external metrics and the internal metrics, you can have your router perform optimal routing based on the overall cumulative cost to get from itself to that autonomous system boundary router, in addition to the metrics that are used at the entry point. So you can manipulate the metrics at the entry point as well and control the overall cost. So it's really giving you, E1 and E2, the ability to define how your routers are going to choose their path to get to those external routing domains. So you have the flexibility, you have the control. So you need to sit down when you're designing your OSPF environment or designing those exit points specifically, and if you decide that this particular exit point should be the preferred exit point, regardless of internal metrics, then you're going to set it to E2, and you're going to have that metric at the redistribution point be lower than the other redistribution points. However, if you need optimal internal routing to get to those external routing domains, then you're going to use E1. You're going to use E1 because then the overall metric is cumulative from end to end.